Now for the next topic, we have operations on harmonic functions. Using the complex number representations, we have your rotating vector. So our rotating vector is represented by our x. So we have here the directions signifying or representing this vector, and that is equal to your amplitude. Okay, and we have your exponential e. So this is raised to your I imaginary, then multiply by angular velocity times time, where my angular velocity, so that is denotes as your radians per second. So I'm gonna state here where my angular velocity is equal to my not actually equal, but this is the unit is, so the units we have here are radian per second. Okay, and for my t, usually this is time, so that is in terms of seconds. Okay, now our rotating vector, which is this one equation, that is rotating in a counterclockwise direction. Now the differentiation of the harmonic motion of this equation is given by with respect to time. So I can write here, so that will be my d, so the rotating vector, so this is differentiated with respect to time, and we can substitute here with respect to time the value of your x bar, so that will be ae. So this is raised to I times the angular velocity times time. Okay, and if you're going to differentiate this one with respect to time, so we have the value of your I, okay, times your angular velocity. So we have your a and e, so we have the exponent, that will be I angular velocity times time, where my this ae, so this is equal to the value of my x bar. So I can further rewrite my equation as this one will become your, okay, so this can become, so this one will become your I, okay, angular velocity times the value of your x bar. So I can represent my equation like this one. Now for the second derivatives of this one, so I can rewrite here, that will be your x bar, second derivative of my motion, here. So with respect to time, so that will be d over your dt. Okay, so times the value of this one, so that will be I angular velocity ae, then we have your I times your angular velocity, then so this will become as so I'm gonna bring down here, that is, this will become your I squared, and times your angular velocity squared, then we have your a, and the same also that is yung nangyari before, and I can, here we have your exponent here, ie, the angular velocity times time, and I can represent my I squared. So going back from my previous lecture, so this one, okay, so you will notice here my imaginary, that is raised to square, that is equal to a -1. So I can replace my equation, the I squared there, and replace it by a -1. So going back, So I can rewrite here, no? So this will become your negative, no? Negative. So I'm gonna replace my I. So negative I square angular velocity, no? Squared, no? A amplitude. Then we have your exponent here. Then raised to I times the angular velocity times time. Okay, so let's have a quick overview of my derivation of here of my angular my rotation of my harmonic functions. So we have here initially, so we have the displacement, this one, okay, and we have here the velocity. So this is my displacement. I'm gonna write here, so displacement of motion, okay, and this is my first derivative. So this will become my velocity, and the second derivative of my velocity, so this will become my acceleration. Okay, now my displacement, velocity, and my acceleration, so this can be expressed, or we can use this to determine the real part of this displacement and velocity and acceleration. So we can express that one, no? So for expressing that one, we have for the displacement, okay, for my displacement, so we have your RE, okay, so this will become we have the real part of my displacement, A raised to your I times the angular velocity times time, no? Okay. We can represent it by using a conjugate now. Using this formula, we have RE, no, is Z, so that represents the function. So this is equal to your 1/2, okay, then times or multiply by your Z. So again, that is function plus the conjugate, no? So conjugate, so that is represented by CUNJ, so that is a conjugate, so that will be conjugate of Z, right? Then close parenthesis. Okay. Now the conjugate of my displacement of my Z as my function, that is equal to my A, okay, so that will be multiplied, so again the value of E, no? So let's go back to my previous lecture. So this one, the value of E, no, E raised to the I times the angle of theta, so this is an equivalent to the value of cosine theta plus your I, then you have your sine theta, no? So using this value, which is yung E raised to I theta is equal to this one, so we can represent the value ng other part ng equation. So going back that one, so I can rewrite this one as my cosine of theta, no, representing this one. So that will be cosine of theta plus my sine of theta. Okay. Then again, so if we're going to make it a conjugate, so eventually so this is sorry, I forgot here we have I, no? So the sign convention of the positive I will be changing to, if we're going to use the conjugate of my E raised to the I W, or the conjugate of this value of my EEI. So I'm going to replace the call this the sign, no? So this, if this is positive, it will become a negative. So this is now equal to your A, no? so that will be cosine of theta, so this will be a negative value, so that will be I times the sine of theta. Okay, so your I will be replaced at the negative sign, no? So if it is a negative, it will become a positive. You're going to replace when you're using a conjugate, when you include it, determining the conjugate of that function, no? Then for my real part, so if you're going to determine the real part, we have your RE, no? So again, we're going to rewrite our equation here, angular velocity times time, no? Now we're going to determine, we're going to just only use the formula here. So here we have 1/2, no? 1/2, okay. That will be multiplied times the z, or the function, so that will be this one, so that will be a raised to I angular velocity times time, no? And then plus your conjugate value, so we have here a, no? So close parenthesis this one, so that will be cosine of theta minus your I, then we have the sine of theta. Okay, so close parenthesis natin yan lahat. And I can express my AE, okay, so this is again equal to this one, so this is will be 1/2, no? Okay, that will be A, so close parenthesis, so that will be cosine of theta plus you have your I sine of theta, and close parenthesis natin yan, then plus, okay, we have your A, cosine of theta minus your I, so this will become your sine of theta. Okay, and close parenthesis, whole equation, no? So I can distribute or expand my equation here, so I have my 1/2, so distributing here, so I have a cosine of theta plus I a for my amplitude sine of theta, no? Then plus that will be a cosine of theta, and this is I a sine of theta, so close parenthesis that one. Okay, and we can combine both terms here, so yung a cosine of theta, and we can cancel this one, so since it has positive and negative values, negative sign convention, so I can rewrite my equation here. We have your 1/2, no? So combining this one and this one, I have a 2a cosine of theta, yun na lang ang naiwan, no? And I can cancel this one and this one, so I have now my real part of my call this real part of my displacement, your RE, no? Real part of my displacement AE raised to I angular times time, so that will be A amplitude times the cosine of theta. Okay, so let's have a quick recap on this one. Okay, so we have here the displacement, so taking the real part of the displacement, we have AE. Okay, so using the formula, so we have the real part of my function is equal to 1/2 times z plus the conjugate of z, okay, and the conjugate of my function AE raised to I, then angular times angular velocity times time, so that is equal. Now the value of this one, so coming from my Fourier series, and sorry, not Fourier series but the Taylor series of expansion, so we have here the trigonometric identities of this one, which is cosine, no? Cosine of theta plus I sine of theta. Now if we're going to use the conjugate of this equation of this one, so this will be equal to A, so I'm gonna change my negative it's the positive sign into a negative sign, so that is the when we're using a conjugate, so we're going to change the sign convention of your I. Now we have A, that will be cosine of theta, then you have your negative I cosine of theta. Now, again, so again, expanding this one, so we have your 1/2, so AE, no? And we have your angular velocity. So this is, again, from this equation, the function of z, okay? So we have your function of z. Then plus AE, the value of the conjugate, okay, this one. And again, we have here the value of your cosine of theta, so this is equal, so coming from my previous lecture, plus I sine theta. Then again, so distributing, so again we have your negative sign will be cancelled out since this is positive and we have here negative. Then combining both terms, so we have 2a cosine theta. Since this is 1/2, we're gonna cancel that one. And the real part of my displacement, AE, so that will be a cosine of theta. Now next for my velocity, again, so the real part from this equation, the real part of that one, no? So we have your RE, okay, so close parenthesis, we have your I, angular velocity, we have your amplitude, and E, so that will be raised to I times the angular velocity times time, no? Okay. Now determine again my my z function. So my z function here, or say the z is equal to your I angular velocity. Sorry, this is okay. So AIW angular velocity, then we have your E, so that will be raised to I angular velocity and time, no? Okay. Then my conjugate here, so I can say that there is 2I here, this one and this one, okay? So the conjugate of this one, so my conjugate of this equation for my velocity, so I'm gonna write here AE, and that will be I angular times time. So I can break this one into 2, no? So that will be the conjugate, no? Conjugate of my I angular velocity, then close parenthesis this one, then that will be multiplied to the conjugate. So I'm going to multiply this one to a conjugate. So conjugate of my AE, that will be I raised to the angular velocity times time, okay? So that represent the conjugate of IE, II times the angular velocity A, or the velocity, no? Where my conjugate, okay, so where my conjugate of your I times your angular velocity, so this one again, so this is a positive, the value of your I is a positive, so I'm gonna change this one to a negative, negative I times the angular velocity, huh? Now for the conjugate of my AE, so that will be I angular times time, so this is equal to again, the value, again this one, so this is A, no, close parenthesis, so again the value of this one, that will be cosine of theta plus sine of theta. Sorry, I forgot the imaginary I here. We have sine of theta, okay? Now I'm gonna change the sign convention here, so this will become now, so by the conjugate, so we're going to change the sign convention, so there will be cosine of theta, so this is will be negative, and I sine of theta, okay? Then I can substitute this one to my whole equation for this one, okay? So I can rewrite that my conjugate, no, my I angular A E I angular times time, so this is the value will conjugate, that will be negative I times the angular, no? Then multiply the value of this one, okay, this one, Okay, so that will be a times the cosine of theta minus my sine of sorry, I forgot my I here, so that will be I sine of theta. Then since I have my conjugate, so I can substitute it to the previous equation, which is your equation, which is this one, no? I can substitute here to get the real part of my equation of my velocity. Okay, the real part of my velocity. So I can write here that my r e, no? So that will be the function of we have the function of I angular AE plus I angular times time, so that will be equal to 1/2, no? So 1/2, okay, times the function, so the function that will be your I times the angular amplitude, we have e raised to exponent I angular times time, no? And minus this one for the value of my conjugate, so that will be negative I angular A. So we have here cosine of theta, that will be I sine of theta. So close parenthesis this one. Okay, and we can call this expand the whole equation, no? This one I can expand this one, so I have here 1/2. So expanding this one will be I angular A. Now the value of this one, okay, so that will be cosine of theta, that will be plus I sine of theta, and this will be minus, so I'm going to distribute, that will be I angular AE A cosine of theta. Then again distribute this one, that will be positive, no? So that will be I squared, so that will be sine of theta. So close parenthesis natin yan. Okay, then I can further rewrite this one and distribute it here to the equation. So we have here, so that will be I angular amplitude cosine of theta, so this will be plus, we have your I squared, and that will be angular A amplitude, then we have sine of theta, then that will be minus I angular amplitude cosine of theta plus your I squared. Forgot here to distribute the values, so I'm going to erase this one, sorry for that one. I forgot to rewrite the coefficient of this one since we're going to multiply, so that will be I angular A, so that will be sine, okay, sine of theta, so close parenthesis, so that will be I squared angular A, and we have sine of theta. Okay, so from here we're able to determine that this one and this one, so I can rewrite here, so that will be the one will be cancelling, is we have my cosine, so this one will cancel out and this one will be cancelled out. Okay, and I can rewrite my equation here, we have 1/2. So combine both terms here, so I have my 2 I squared, okay, angular amplitude, then sine of theta. Okay, then I can cancel this one and this one, so finally, no, the real part, okay, the real part of my equation of angular, my velocity AE raised to I angular times time is now equal to this one. Okay, so that will be equal to I squared angular A sine of theta. no? Now going back from my previous lecture, so the I squared, no, this one, so this is equal to -1, no? So let's try to substitute that one, no? So my real part here, so again, so that is I squared, so we change to negative, so we have here the real part of my velocity, that will be angular velocity A amplitude sine of theta. Okay, so that will be the real part. So let's have a recap of this one. So let me do a quick overview. Okay, so for my velocity here, so we have the real part of my velocity, so we have I times the angular velocity area amplitude, then we have your E to the exponent angular and time, no? For the function, so we have this one, okay, so my velocity and the conjugate of my function, so that is the conjugate of I, which is coefficient of I, W, okay, times the conjugate of my AE times your I, exponent of I, and angular velocity times time. Now for the conjugate of I and angular velocity, it will become a negative, no? And for this one, since our E is equal to cosine of theta and sine of theta, so usually we have your negative, it will be changed to positive. We have a positive, then we're going to change it to -1. So again, conjugate of my velocity is equal now to your negative I angular amplitude and cosine of negative I sine of theta. Now for the real part, so again we're going to substitute this one to the equation previously that were used. So we have your RE Z 1/2 times Z times the conjugate, no? Okay, so substituting that one in equation, so we have here 1/2 function, no, the velocity and my conjugate values here. Now so as I expand this one, so this is equal to cosine of theta plus sine of theta, I sine of theta. Then so after expanding, okay, so we can distribute now, canceling both common terms here. So we have here, this is positive and we have a negative cosine here, so cancel this one, and combining the both terms, so we have I squared angular, and it will be 2 I squared angular amplitude sine of theta. So cancel this one, this is 2, and this is 1/2, and this is 2. Then finally we have arrived, that will be I squared angular amplitude and sine of theta. Since the value of my I squared, no, that is going back, so my I squared is equal to -1, so I can substitute that one here, so replacing my I squared into a negative value, so I have my real part, which is negative angular velocity times amplitude then sine of theta. So that will be the real part of my velocity. Okay, and also we have from my trigonometric identities. From my trigonometric identities, my sine of theta, okay, so that is equal to cosine, no, cosine of theta, so that will be minus 90 degrees. So from here we have sine of theta, so I can substitute that one there, no, so I can rewrite my equation, no, so for my real part, so that will be, I can rewrite this one, my real part, so that will be I angular E raised to I, so that will be angular times time. Okay, I can rewrite here, that will be negative angular, that will be times your A, then the value of my sine theta, so that will be cosine of theta minus your 90 degrees. Okay, and I can put there, distribute the sine values here, so I can rewrite my angular velocity, so that will be cosine of theta, that will be plus 90 degrees. Okay, now for my acceleration, the real part here, RE, okay, so that will be negative values. Here we have negative angular, so that will be squared. We have your a, and we have your exponent e raised to I, angular velocity times time. Okay. Now my z function here, so that will be equal to your negative angular velocity squared, so that will be a raised to I. This will be angular, okay, times time. Then the conjugate of this one, conjugate of my negative angular squared a e, that will be I angular times time. Okay, so this will be equal to negative angular squared. We have your a, then the value of this one, so that will be equal to cosine of theta, that will be plus I, that we sine of theta. Now for the conjugate of this equation or function, that will be equal to your negative angular squared area. So I'm gonna change the sign convention here. So cosine of theta, that will be negative, that will be I sine of theta. Then again, so substituting again to the equation, so we have the real part of the is equal now, so this will be your I angular times time, so this will be equal to 1/2. Okay, then the value of the function, so that will be negative angular so that will be angular squared, a, okay, then times the value here we have this one, so that will be cosine of theta minus your I sine of theta. Okay, I forgot, we need to step aside here this one and move the value with angular velocity. So I will try to erase this one, so changing this one. So I have here the value AE, so that will be I angular times time, then minus the conjugate, so this is 1/2 function, then the conjugate, that will be a negative value yung conjugate natin, so that will be angular velocity squared. We have your A, so that will be cosine of theta minus your I sine of theta. So close parenthesis this one, so this will be equal to 1/2, and this will become your angular velocity A, and this one value, okay, so that will be cosine of theta, that will be plus your I sine of theta, and distributing this one will be your angular squared A, and that will be multiplied by cosine of theta, sorry, this is cosine of theta, so that is negative, it will become positive, so this will be I angular squared, we have your A sine of theta. Okay, and I can further distribute this one, so that will be 1/2, so that will be negative angular squared, we have here A amplitude cosine of theta, so this will be, sorry, this will become negative, this will be negative I, then angular squared, then we have sine of theta, minus your angular squared A cosine of theta, and this will be plus I angular squared a sine of theta. So which one will be cancelled out? So that the sine will be cancelled out. So this will be minus positive, and we have a minus, so cancel out natin yan. So we have the value that will be 1/2. So combining both terms, we have negative 2 angular squared a cosine of theta. So again, I can cancel this one and this one. So I can rewrite my real part, which is equal to negative angular squared a e I angular of time. So this will become negative angular squared a cosine of theta. Okay, so this equates the real part of my acceleration. So that will be negative angular squared a cosine of theta. Okay, so let's have a quick recap on this one. So the acceleration, the real part of this one again, so, and we have here the function, okay, of my acceleration, this equation. Now for the conjugate of this one, so we have here W as angular velocity squared, area, amplitude, and we have E. Okay, so expressing this one as a cosine, and that will be I sine of theta. So we're going to change the sign convention. We're getting the conjugate. Okay, then from my equation, so I can substitute that one by z. Okay, this is the value of z as my function. Then the conjugate of my z, conjugate of my function. Okay, this one. Then expanding my equations, so from substituting also here and also distributing the values of W squared and amplitude, so we gain this expansion. Now again, expanding this one distribution, and from here we have the negative sign and positive sign, so it will be cancelled out, so it will be 0 out. And here we have a common sign convention, so it will be negative, so we have the negative 2. Then from my 1/2 here will be cancelled at the 2, so what is left is the negative angular squared a cosine